I got to make sure I get them all together for a photo, right? So we can put it up on our website so everyone can be able to see where all of our funds are going in PKU research. So we have one more update for you before the end of our sessions today, and that is an update from Tom Franklin, who has been coordinating for several years our challenge that we held to develop a home fee monitor. The development of a home fee monitor you heard about this morning from Betsy. It has also been a top priority of our scientific advisory board for the last several years, and are happy that Tom can provide us with an update, and I'm sure he'll be very interested in hearing what he has to say.
Thank you, Christine. It has been a challenge working with this home fee monitor development project over the years. So for those of you who haven't attended our sessions in the past, I'd like to sort of review a little bit of the history of our fee monitor development project. We actually partnered with InnoCentive Ink and the Peter Cundall Foundation back in 2013. InnoCentive Ink was a spin-out of Eli Lilly. Back in the 90s, Eli Lilly had problems internally. They would submit them out to their whole employee base to see if anybody could solve their problems. And that was such a successful activity that they actually spun that out as a standalone company, and that's InnoCentive Ink. They have over 300,000 solvers now across the world to help solve problems. And their clients span all the way from Department of Defense, NIH, major companies, major corporations. In fact, some of us, particularly Dick Michaud, did a little due diligence on them and talked with a couple of their clients and found out that they were a good group to work with. So we partnered with them back in 2013 and helped put together a challenge statement that InnoCentive sent out to their solvers across the world. They also helped us go up to Toronto. Dick and myself and InnoCentive folks went up there and made a presentation to the Peter Cundall Foundation, and they agreed to help fund our development project. So between the Alliance and the Cundall Foundation, we put together a little over $750,000 to pursue this challenge project. We thought we might receive 40 or 50 proposals from across the world. We actually got almost 130. And of course, they came from 7 different countries. We didn't have enough brains internally or even on our scientific advisory board to evaluate the technologies. They were electrochemical technologies, colorimetric, spectrometric, laser reflectometry, UV absorptometry, antibody technologies, RNA and DNA atomic technologies. They're just all over the map. So InnoCentive helped us put together a panel of experts, again, from across the world. We had experts from the UK, Israel, India, and the US. I think we had about 12 or 14 judges on our panel that helped us wade through all of these proposals. We picked 10. First, to become a solver and put a proposal in, they didn't get any money. You just put a proposal in. And then we selected 10 that we would give $10,000 to go back and give us a little bit more detail, put together a project plan. And then we selected, I think, 5 or 8. I can't remember now. I think we were going to select 5, but I think we ended up giving 8. Another $10,000 to give a more detailed plan and actually go to your workbench and see if you could demonstrate your technology. And then we picked 3 of those that we gave $50,000 to go back and develop a prototype that could be tested in a clinical setting. And with the help of Dr. Ronnie Singh and her crew down at Emory, we took those 3 solvers into a clinical setting where Ronnie had pulled together a whole slew of PKU subjects from low Phi to mid Phi to high Phi. But unfortunately, in testing these prototypes, none of them met our expectations or the specifications that we had set out. So we learned some lessons from that experience. We found that the solvers were having issues with enzyme stability. They were having lot variations from their vendors, so they had trouble calibrating their devices. One of them particularly used whole blood, which caused all sort of background noises. And so what we learned, we needed to separate the whole blood specimen and do the analysis on a good, clean plasma sample. And you could do that by using microfluidics or filtration technologies that would separate the blood components from the plasma. And then we also said, well, maybe we need to look at some other potential technology. We obviously saw a lot of other technologies in our challenge projects. But anyway, Dr. Elaine Fu was one of the solvers that we were really infatuated with because she had a simple paper technology that required no electronics. And we thought, boy, if that could work, it could be used in third world countries and all over the world. And so we kept supporting her. In fact, I think we're still supporting Elaine in her work at Oregon State University. She's at a stage now where she's ready to do some clinical studies, hopefully in Dr. Vockley's laboratory at UPMC Children's in early 2019. Clarence DeFauld was another one that was in the antibody technology field, but they had funding issues and they also had company priority limitations, and they fell out of the race. In Dr. Fu's progress on her Phi test, she's partnered with, again, I said Dr. Vockley at UPMC Children's, also Oasis, which is a paper technology company that allows you to put various sorts of things on paper, various chemicals to run various tests on. As again I said, her technology is very simple. You put a drop of blood on a card and let it run through a filtration process through the various chemical stages, and then at a certain period of time you fold a part of the card back on itself, and there's a dye that changes colors, and you look at that dye and it tells you qualitatively whether it's high, medium, or low Phi. Well, in some instances that may be good enough. But a lot of folks, in particular our scientific advisory service, said, no, we really need quantitative measurements on our Phi. So what Elaine is doing now, she's adding an optical reader to that dye so you can get quantitative analysis of it. And hopefully we'll see some results when she gets in a clinical setting with Dr. Vockley. There were additional solvers that didn't participate in our challenge project, mainly because there were IP issues. We required every solver that put in a proposal to us to be willing to give the alliance a non-exclusive license. Some of the technology, some of the solvers, or some of the researchers had already licensed their technology to other companies, and so they could not participate. Dr. Marshall Summer and his group at Children's National Medical Center in Washington was one of those. They had actually licensed their technology to a new startup company called Archimedes, and they really addressed the enzyme instability issue by finding a bacteria that could withstand a lot of temperature ranges, and that actually made PAH. So they cultured this bacteria and harvested the PAH, and then they could use that in their analysis for their Phi monitor. And Archimedes is in the process of raising money to continue the development of that monitor. Dr. Vamsi Pamalu down at Babies in Research Triangle. Babies is a neonatal screening company that's been involved in a lot of other biomarkers for neonatal screening, and they've taken on Phi as one of their challenges to add to their array of analysis. In fact, Aaron Fry and Daniel Hall are here from Babies, trying to learn more about PKU and how their monitor would help the folks in the PKU community. They have also been successful at getting NIH funding and are going to be working again with Jerry Vockley at the UPMC to test their device. Then there's a fellow at Clemson. I don't know, is Dr. Latour here? He's way back there in the back. Yeah, I haven't met him yet, but I've talked with him on the phone many times. Dr. Latour is an engineer at Clemson. And I have to say this, I've been an academician for 23 years of my life, so sometimes when you work with folks in the university system, they have all these great ideas, but they don't really relate to the real world sometimes. But I can say that's not true for Dr. Latour. He's got a team of people that'll knock your socks off working with him. But again, he's working with a urine sample. Now, when we went through the challenge project, we didn't think much of urine sampling. I mean, we had people that wanted to sample tears, spit, and pee. And we said, you know, there's so much problems with the hydration of the patient and knowing, you know, what the concentration is going to be. But Bob down at Clemson, they says, okay, we realize we got a problem in measuring urine, so we have to know how much flow is going through the kidney. So they're actually doing a creatinine measurement and looking at creatinine and phenylpyruvic acid ratio to determine the Phi levels. And I'll show you a little bit more of the details of their study, but I've been impressed with his team. The Babies technology, again, we started talking with the Babies folks back when they were, what was it? It's advanced liquid logic. That's before they became Babies. And in fact, we've written several letters in support for SBIR projects for these folks down at Research Triangle. And luckily, you know, they finally got funding from NIH this past year. But their technology is they have some really unique digital microfluidic technologies, and they use electrical currents to turn things on and off. You put a drop of blood on a card, and they do some fancy stuff to get it to move through the card and go through all the chemical interactions and give a result. The device shown here is sort of a prototype concept. They typically make devices that they sell to hospitals or clinical labs, so you do the testing right in the physician's office. In fact, one of the ideas is that when you go to see your metabolic disease specialist, they could do the test right in the office and get your results immediately. But they recognize that that needs to be simplified, you know, for a home Phi monitor, and so they're taking the steps to minimize it so it can, I mean, we don't want a huge big machine working in a home Phi monitor. It'd be nice if there's a handheld type device. So anyway, they're working with that technology. So you'd put a drop of blood on not a card, but a cartridge, I guess they call it, and then plug it into the machine and read the results. As I mentioned, the team that Dr. Latour has put together down at Clemson, in fact, Rodney Howell was very, very instrumental, and I wasn't very interested in talking more, but talking with Dr. Howell on our scientific advisory board, he said, first, you know, are they working with any clinicians down there? And I said, well, they're working with a group over in Greenwood, South Carolina. And he says, is that the Greenwood Genetics Center? And I said, yeah. And he says, well, that's one of the best genetic centers in the nation. In fact, one of his old trainees and a past roommate of mine started that clinic way back yonder. So Bob Latour is collaborating with the folks at Greenwood Genetics Center in Greenwood, California, Greenwood, South Carolina, and also with Ronnie Singh down at Emory. And the fact that he's university-based, he's not into the medical device manufacturing, so he's developed relationships with companies that are already doing creatinine measurements, and also a company that could maybe put together a device that would be the final prototype to use for the testing. They've done some preliminary results with getting some samples, I think, from Greenwood and maybe also from Ronnie Singh down at Emory. And this just shows the top, they call them coupons. They show that the top colors there are from the phenylpyruvic acid analysis, and the bottom part is the creatinine analysis, and they do a ratio and then compare that to the actual plasma amino acid analysis, and are getting some very good results, and particularly at the lower levels where most of the people are having trouble. So in addition to these, there are several other ones. Rob Harper at In Vivo Diagnostic Solutions is here. By the way, Dr. Latour and Rob Harper both have posters in the session this afternoon, so you can go and see their posters and see more details of their technology. But Rob and Dr. Saran Agajanian of INSA, they're enzyme specialists, and so they've solved this enzyme instability issue that other solvers have, and so they're working on a device. Peter Warhol and EGOO, I don't know if it's EGOO or EGOO or EGOO Health, they're in Denmark, and they're interested in fee monitoring for a long time. Peter's been interested, for years, and he's found some fluorometric technology that was really published way back in the 60s or 70s, and he's making that work in his device. And in fact, they're partnering with our folks over in the Netherlands. They have a fee day coming up in September, and they're going to have 35 or 40 of their devices over in the Netherlands on fee day to really give it a try and see if this technology works. So we're really looking forward to that. And then there's a team at the Institute of Bioengineering at Catalonia in Barcelona. We've talked with them on the phone a couple times. They're using some unique aptamer and nanoparticle technology. When we talked with them, they were just in the proposal phases of getting funding to do that, and we haven't had an update on that. But we do know that we talked with some aptamer technology folks back at the start of our challenge project at Columbia University, and they also had some intellectual property issues and couldn't participate in our challenge, but they're pursuing aptamer. Actually, it's a single-strand DNA aptamer technology that they've licensed or started a new startup company called Aptatech Bioscience, and some of the folks are here today from that company that's spun out of Columbia University. The in vitro diagnostic solutions, and you maybe see this, I don't know if Rob will have his sample. He's got a little a handheld, as pictured in this slide here, where again, it's a similar technology of use as Elaine Fu's. You put a drop of sample on something, you fold the card over, and then you stick it in a reader. So you get to see his poster session this afternoon, and maybe talk with him about more details and where he's going and what's his hopes of getting this finalized. The EGOO Health prototype, they have some real interesting technology. They're into the Internet of Things. I don't know if you folks know what the Internet of Things are. I didn't know what it is. They call it the IoT, and everything is going up into the cloud, and their readings from they have all sorts of biomarkers that they're already doing with other diseases, and the information goes up into an iCloud, and it goes to your doctor's office, it goes to your iPhone, and it goes all over. So they have some interesting stuff going on there, and it'll be interesting to see how that study goes on PKU Day over in the Netherlands here in September. But they've been very successful, and this is sort of a picture of their, what they usually call their trace device, but it has various modules that you put in. You put a drop of blood on and then put it in the device. And they're already doing lipid panels and C-reactive protein tests and hemoglobin A1C test. So they're in the biomarker business, and they know what they're doing. And in fact, I think Dick and Jenny visited them here a year or so ago, and we're very impressed with their technology and their capabilities. So we're keeping an eye on the folks there. So our next steps, we obviously continue communications with our solvers, the ones that are in the challenge and those outside the challenge. We're currently partially supporting Dr. Fu's work at Oregon State, Dr. Latour's work at Clemson, Dr. Warhol's work at EcoHealth in Denmark. We've written letters of support to Dr. Fu and Dr. Latour, Babies, EcoHealth, Archimedes, and in vivo diagnostic solutions to assist in their funding efforts. I know Rob Harper's been successful at IVDS in getting funding. I think it's SBIR grant that they've got funded to help their work. So we'll continue to support these efforts until we eventually get a fee model. You know, a long time ago when we started this, Jenny Michaud said it's always better to have more horses in the race than just one. So we got a lot of horses in the race, and so hopefully one of these days, and you know, I said this at our last meeting, one of these days, so hopefully when we come back in 2020, we'll have a fee monitor, if not by then. Thank you very much.